These examples are asking us to, they're giving us an x value, which you can see in each of the parentheses. So those are each x values, and they want us to plug it into the function. But the tricky thing is that there are two pieces of the function. In the first piece, all my x values are less than 3, and in the second piece, all of my x values are 3 or greater. So what I find helpful to do is to make a number line. And whatever your boundary number is, and your boundary number you can see because it's the one that's used in the inequalities, whatever your boundary number is, I like to make a number line, and then it's easier to see where these numbers fall. So I'm going to do some points on the number line. So this would be 2, 1, 0, -1, -2. And then I'm going to do some more on the right, 4, 5, 6, 7. So now that covers all of the x values that I'm going to be asked to plug in. So again, this right here, this 3, this is my boundary line. And then I have two sections. So I have section 1 and section 2. Section 1 is everything less. Section 2 is everything greater. All right, so I want to find f of -1. So the first thing we have to do is figure out what section -1 falls into. So I'm going to look at my number line down here, and here's -1. I'm going to put a star on it. So -1 fits into section 1. So what I'm going to do now is take the function for section 1, which is 3x plus 6, and now instead of x, I'm going to plug in -1. So 3 times -1 plus 6, which is -3 plus 6, for a grand total of +3. So that's our answer for part A. Now we're going to do the same thing with part B. So now I'm asked to find f of 6. So here is 6 on the number line. It's a little hard to see, but it's a green star. 6 falls into section 2. So that's this function right here. So I'm going to copy down the function, and you'll notice that there is no x. So what that means is that even though I was given an x value, I have nothing to plug in. This is a constant function, meaning no matter what x value you're at, your answer will always be 5. So the answer here is 5. And then the last one is tricky. It's asking us to find f of 3. F of 3, if you look, is right on the boundary line. So at this point, we need to look a little closer. When you look at your constraints, you're looking for the one that has the equal to sign. That's the one that 3 itself is included in. So I see that right here. That means it's in the bottom. It's in section 2. So I'm going to copy down the function for section 2, which is 5. And we just talked about this, how no matter what x value you have, since there's nothing to plug in, your answer is going to be a constant number of 5. So this time we're given a function that has 3 parts. So what I'm again going to do is kind of label my number line. So I have 3 different numbers in my, if you look at my constraints right here, there are 3 different numbers. I have -4, 5, -4 happens twice, and then 7. So this first boundary line at -4, and then I have one at 5 and one at 7. So here's what's going on. I have my first section is everything to the left of 4. So the first section goes to the left of -4. The second section is saying that x is between -4 and 5. So this is the section 2. From here to here. And then section 3 is saying that it's everything to the right of 7. So this is section 3 over here, everything to the right. So there's actually a section between 5 and 7 that is not defined as part of our domain in this function. So what that means is if we have any numbers that fall in this section right here, our answer is going to be that it's not in the domain. So we can't do those problems. So let's take a look at part A. So I'm looking for the x value of -2. If you look at my number line down here, -2 would fall somewhere in here. So that would be in section 2. So I'm going to use the function from section 2, which is the absolute value of x plus 2. So what I'm going to do now is I'm going to replace x with -2. So -2 plus 2, which is actually 0. And the absolute value of 0 is 0. So that's your final answer. For part B, I'm looking for f of 3. So I'm going to figure out where the x value 3 would fall, and it actually also falls in section 2. So I'm going to take the function from section 2, which was the absolute value of x plus 2, and I'm going to plug in 3 for x. So I end up with the absolute value of 5, which is just 5. Next, I'm going to figure out where negative 4 falls. So negative 4 falls on a boundary line. So when that happens, you need to go back to your constraints up here at the top, and you need to figure out where the inequality with the bar underneath it is. So if I look here, I see 2 places where negative 4 is used, but I want to use this top one because that one has the equal to bar. So that means that's exactly where negative 4 falls. So I'm going to use the function x minus 7, and I'm going to plug in negative 4 for the x. So my final answer would be negative 11. For the next one, f of 6. So 6 is my x value. If I look at my number line here at the bottom, 6 would fall about right here. And that's in that section that I put a star next to because that's not part of our domain. So we're not going to be able to do this problem. So I'm going to write not in domain, and we can move on to part E. So now we're looking for f of 7. So x is 7 now. So I'm going to look here, and x being 7 is right here on a boundary line again. So I need to go to where my original constraints are, and I'm going to look at my inequality, and I notice that it does not have the bar underneath. What that means is that this is another problem that is not in the domain. In order for it to be part of the domain, it has to have the equal to bar underneath it. And then my last problem is f of 10. So if I look at this one, 10 is my x value. 10 would be somewhere over here on the number line. So this tells me that it's part of section 3. So the function for section 3 is negative x cubed. So I'm going to plug in negative 10 cubed, and my answer here would be negative 1,000. For this first example, we're graphing 2 pieces of a graph. The first section, which I'm going to circle in blue, is from the linear family, so that's going to be a line. And then the second section, which I'm going to circle in red, is from the quadratic family, so that's going to be a parabola. So the first thing we need to do is worry about our boundary lines. So it tells us in the blue one that graph will occur when x is less than 0. So that's talking about when x is to the left of 0. And then the red one tells us that it's going to happen when x is greater than or equal to 0. So the first thing I want to do is draw in this boundary line. So I'm going to draw it in I'll do yellow. So here's my boundary line at 0. So to the left of the graph, to the left of the boundary line, I'll have the blue graph, and to the right of the boundary line, I will have my red graph. So what I did is I put screenshots of what you should put in your calculator. So the only thing you're going to need to know how to do in your head before you get started, you're going to need to know what number to start on each of your tables and whether your number should be going up or down. So your boundary line is always where you're going to start. So 0 is going to start your first boundary, or your first table, and then 0 will also start your second table. From here, because our first part of the graph is less than 0, I want my x values to go down in value. And then for the second part, since my x values are going above 0, I want to go towards the positive direction. Now, the last thing we need to talk about before we look at these tables a little more closely is the open and closed circle business. So remember that if you have less than or greater than, you're going to use an open circle. And if you have less than or equal to, greater than or equal to, that's when you use a closed circle. So for the first part, if you look at the inequality, right here, it does not have the bar underneath. So this is going to be an open circle. And then on the second part is where we'll have our closed circle. So these points where you have the same x value, you should always have one of each, one closed circle and one open circle. Sometimes those points are going to actually link up and become one point where the graphs connect. Sometimes they're going to be disconnected, and you'll actually see that one of them is open and one of them is closed. So what I like to do now is start from my smallest x value, and I need to fill in my tables, but I'm going to start from my smallest x value when I graph, and then just work my way towards the highest x value. So you'll notice on the right bottom corner, I have some pictures here. So this first one here that I'm putting a star next to or on top of, that's what I put into my calculator. So in Y1, I put the blue function, and in Y2, I put the red function. And then I went to my table, and that's what this is right here that I just drew an arrow towards. So what I have highlighted here is that boundary number. So this 0, that's my boundary number. And then I'm going to go and I'm going to look at the blue numbers first. Now remember, I'm going towards the negative x values. So I'm using -1, -2, and -3 along with 0. So I want these 4 numbers to go into my blue table. So 0, 0, -1, -1, -2, -2, and -3, -3. Now I'm going to look at my boundary line again, so my 0, but now I'm going to go up in my x values. So I'm going to use 0, 1, 4, and 9. Okay, so now I can actually graph. So like I said, I'm going to start at my smallest x value, which is -3 right here. So I'm going to do -3, -3, -2, -2, -1, -1. And now I have to pay attention because I'm on my boundary line. So at 0, 0, I need to make sure I have an open circle. So this is the line that goes up to the boundary line. So that's from my linear family. Now I'm going to do the red graph. So I'm going to start at my lowest x value and continue working towards the highest. So I see my first point here is 0, 0, and I have a closed circle. You'll notice that I have an open circle there already. So I'm basically just going to fill it in. So now it's a closed circle. And then I have 1, 1, 2, 4, and 3, 9. So in this graph, my two pieces did connect. And when that happens, it's going to be one big piece, and you're not really going to see the open versus closed circles. That part you will only really see when you have a graph that does not connect, which you'll see in the next example. Okay, so we have two new graphs here. We have the first part, which is the quadratic family. So that's going to be a parabola. And then our second part is an absolute value family. So that's going to be a V. And it's going to be upside down because I can see it's reflected. And then I also have my boundary number. So it's already filled in for us this time. So for the second part, x is going to be greater than or to the right of 1. And then for my first part, everything's going to be less than or to the left of 1. So I'm going to put in that boundary line. This time it goes in at 1. And this is going to divide the pieces of my graph. So now the next thing I want to do is fill in my table. So I want to always start at the boundary number. So both of my tables are going to start at 1. And then for my blue table, I want all the values that are less than 1. So I'm going to use 0, -1, and -2. For the second table, I want all the numbers greater than 1. So 1, 2, 3, and 4. And then the last thing we need to talk about before we take a look at the table is the open and closed circle business. So if you look here at this inequality sign that has the bar underneath it, that means this one will get a closed circle. And then this inequality here does not have the bar, so this is going to be an open circle. So now I'm going to take a look at my table. And again, this is what you would put into your calculator. Right here where I'm drawing a star, you would put in the first function for y1 and the second function for y2. And then when you actually look at your table, which is over here on the right side at the bottom, I have the boundary number highlighted. That's my x value of 1. And now to fill in my blue table, I want my numbers to be going down. So I'm going to use these numbers here. So I'm going to just copy them down. So 1, 1, 0, 0, -1, 1, -2, 4. And then for my second one, I want to use my numbers going up. So I'm going to be using these 4 numbers. So -1, -2, -3, and -4. So it's really important that when you're looking at these tables on the calculator, that your numbers are going opposite directions. You don't ever want to use the same numbers. The only one that should overlap is your boundary number, and that's the 1. So that's why that's included in both of my little circles here. Okay, so now let's start from the left. So I'm going to do this point first, -2, 4. So that's up here. -1, 1, 0, 0. And then at 1, 1, that's on my boundary line, and I want a closed circle. So on the left side of my graph, I have part of a parabola. And then on the right side of my graph, now I'm starting at 1, -1. So that's down here, and you'll see that they do not match. They're not the same point. So that means we're going to see the blue closed circle and the red open circle. All right, so now I have 2, -2, 3, -3, 4, -4. So this is the right side of an upside down V, but because you're only looking at the right side, it kind of just looks like a line. All right, last example. This one is the most complicated because now it has 3 parts to it. So we're going to have to fill out 3 tables, and we have 3 functions. So the blue one is going to be this first function, and that is actually a constant function. What that means is it's a straight line, but it's horizontal. My second graph is from the linear family. This is going to be, it's like the parent function that's reflected. And then my last section is from the quadratic family, so that's going to be a parabola. All right, so I've got my 3 parts. So let's go ahead and fill in my x values. So for my first family, it's telling me that x is less than or equal to -2. So that's going to be the number that I start with. It's also going to be the number that I start with on my second graph. Now, because I have this middle section, this is going to change things a little bit. So my middle section starts at -2 and it ends at 0. So I have 2 boundary numbers in my middle table. And then my third section starts at 0. So now what I need to do is pay attention to where these numbers are going so that I can fill in my appropriate x values. So if I take a look at the blue part, I'm talking about all the numbers less than -2, so that would mean -3, -4, -5. For my middle table, I'm talking about the numbers between -2 and 0, and there's only one number in between those two, which is -1. And then for my last section, it's everything greater than 0, so I want 1, 2, and 3 as my x values. So let's go ahead and put those boundary lines in to my graph. So I want one of them at -2. And then I want another one at 0. Okay, so now I'm going to take a look at the table on the calculator. So over here where I'm putting a star, that is what you should type into your calculator. I like to put them in order. So my blue graph is my constant function, and you'll notice that all of the y values are the same. That's why it's called constant. It never changes. So this is going to be what I'm going to plug in for all of my numbers below -2. And you can't actually see all of the numbers we're going to plug in, but you can see that they're all -3. So I'm just going to copy those down, all the -3s. Okay, and then for my red graph, I want all of my x values between -2 and 0. So at -2, I have +2, and then +1 and 0. And then for the black graph, I want to start at 0, and I'm going up to 3 for my x values. And when I'm talking about those numbers, I'm talking about these x values that are over here, and then the y values that I'm circling are the ones I'm actually putting in my table. All right, last thing we need to talk about before we actually graph are these open and closed circles. So I'm looking at the inequality for the blue graph. I see that I have a bar underneath the inequality sign, so I'm going to be putting a closed circle here. For the second part, neither of those two numbers have the bar underneath the inequality. So that means I'm going to have an open circle here. Oops, I used the wrong color. I'm going to have an open circle here and here. And then for my third part, I have the inequality the bar underneath the inequality, so I'll have a closed circle at this boundary line. Okay, so for the blue graph, I'm going to start with my least x value and work my way up. So here's, let's see, -5, 3, 4, 5, -3 would be here. -3, -3, -4, -3, and now I'm on the yellow boundary line and I want a closed circle. So I'm going to put a big closed circle here. So the only time that open and closed circles matter are on the boundary lines. Everything else is just like a little point that you're going to use to connect the dots to make your graph. Now for the red graph, I'm starting at -2, +2. So that would be up here with an open dot. -1, 1 is just a regular point that I'm going to use to connect the dots. And then at 0, 0, I have another open circle. So I'm going to connect those. It's just a little tiny line segment. And then for the third graph, my point starts at 0, 0. So that actually matches up with this open red circle. So I'm going to fill it in. And then I have 1, 1, 2, 4, and 3, 9. So here's my parabola.